Have you ever wondered why the Earth is only planet in the inner solar system with liquid water on it? Sure, Mercury and Mars have ice caps, but none of them can hold water in liquid form. Today, we will know how water ended up on the Earth, and why didn't it disappear? Most common answer, and what many know, will be from comets. Comets are basically large ice cubes. Their origins may differ as the long-period comets, which generally are the ones which take more than 200 years to complete an orbit around the Sun. These types of comets generally originate in Oort cloud, and the ones which take less than 200 years to orbit around Sun generally originate in Kuiper belt. The pieces produced by colliding KBOs can be influenced by the gravity of Neptune and thrown inward towards the Sun. Because of this, the comets may also collide with planets such as Earth. One of the most recognized cometary impacts, witnessed by astronomers, was the collision of comet Shoemaker-Levy 9 with Jupiter. When the comets bombard, as they contain ice, they can be the source of water to our planet, but how many comets would it take to fill the oceans that we see? Comets come in all shapes and sizes, but if we take an average sized, it would have taken over 10 million comets. It is a lot of comets. In the early solar system, it was common, as we can see our moons and other planets filled with crater. But not all comets have same water as on Earth. Some of them have heavy water. It is a molecule with an oxygen and 2 hydrogen atoms. The heavy water has an isotope of hydrogen called deuterium. So not all the comets contribute to the water on Earth. Not only just comets, but asteroids contributed too. But not all of them. The carbonaceous chondrites have the water similar to the isotopic similarities with water on Earth. Water may also have formed by solar wind, as the solar wind have charged particles, primarily protons and electrons, along with some heavy ions. Solar wind carries a significant amount of oxygen ions as well. These ions, after undergoing complex chemical reactions, can form water. Evidence from probes and rovers suggest that. The other planets had water too in the early periods, but they lost it eventually, or it got locked to the poles. What makes Earth special? The early solar system had the young Sun, which made it possible for water to exist until it matured, and its radiation stripped all the water and left them dry and rocky, including the Earth. The comets hit Mercury and other planets too. That's why we can find some ice in the craters of Mercury and our Moon. But there are conditions. In case of Mercury, it was too close to the Sun, resulting in intense radiation exposure. This caused the planet to lose its atmosphere, leading to extreme temperatures. Due to the solar winds, Mercury leaves a trail of sodium into space, just like comets. Because of these conditions, Mercury cannot hold water. Next is Venus. We previously discussed the importance of an atmosphere, but it also needs to be present in the right amount. Venus likely had liquid water in the distant past. However, due to its thick atmosphere composed of carbon dioxide, nitrogen, and sulfur dioxide, combined with active volcanic eruptions and severe global warming, its temperature rose to the point where even lead would melt. If any water had existed on Venus, it would have boiled away. Now, shifting our focus to Mars, scientists suggest that water on Mars may have undergone processes due to its severe conditions, including dissociation and photodissociation. These processes led to the gradual loss of hydrogen and oxygen components from the water over time. The cooling of Mars's outer core and a decrease in its spin resulted in the loss of its magnetic field. This made the planet more vulnerable to the erosive effects of solar wind. However, the primary reason for the disappearance of water and the thinning of Mars's atmosphere is its lower gravity. Mars's gravity is not strong enough to retain its atmosphere effectively, allowing the erosive solar wind to strip away gases over geological timescales. This combination of factors contributed to the disappearance of water from Mars. The just right atmosphere, robust magnetic field, and also the placement of Earth in the habitable zone, which provides the temperature for the water to exist in liquid state. also called Goldilocks zone. All these conditions made it possible for Earth to hold water on it. So this was how the water came to Earth and how it sustained on it, even though other planets had their chances. If you like to see more interesting videos, don't forget to like, share and bombard the subscribe button for AmpleQuasar. Feel free to use the comments section for more suggestions. Until next time, keep thinking.